Okay, so we're going to go over the, it's the cylindrical shells problem from the review. So after going through it, I realized what was completely going wrong is I was looking at, on number 17, I was looking at it as y being the axis of rotation. So when we were setting it up, it wasn't setting up correctly. And that's what was so wrong. And then I'm going back over it, and obviously I have made a huge mistake, and it is y equals 0 is the axis of rotation. So let's look at that just to keep that difference separated too so that I didn't confuse anyone too much. Let's go through. Let's make our axis here. It's a really thick pen. So on here, let's do, okay, so we had one graph that was going through at 1, another graph going through at 1, so we have y equals 1, x equals 1, and then we have this graph that is coming up through here. And I don't think the question was so much how to graph, from what I understand. It was how to solve just the cylindrical shell problem. Okay, so in the problem it states that the axis of rotation is y equals 0. Well, y equals 0 is here. So this is the axis of rotation. So it's going to be rotating around the axis y equals 0, which is the same thing as the x-axis. So make sure you're reading those closely so that you don't get confused. Because what was confusing to me is that when you set this up, cylindrical shells will always be parallel to your axis of rotation. So when we were setting up these cylinders, when I had it set up as rotating around the y-axis, that's what was so confusing to me. I couldn't figure out why they were rotating around that axis if the shells were going this way. Okay, so now that we have it set up correctly, we have the correct rotation, these pieces now are what are going to be rotating around, creating the cylinders around each of these as it rotates around the x-axis, or y equals 0. Okay, so it's important to understand the pieces of the equation for cylindrical shells. So the when you're looking through, you have 2 pi times the integral from a to b of y. And on this case, because the equations that we're given are written in the form x equals, we're going to differentiate with respect to y, because this is a, well, let me go back here, sorry. Because if you think of it as an equation solved for x, it's x as a function of y. So y is your variable that you're working with, and that's why then this would be a dy equation. So we'll have y times f of y minus g of y, and this is taken with respect to dy. Now when you're looking at what the area of a cylinder is, it's 2 pi RH, the surface area of just the outside of the cylinder. So if there's not the circles on the top and the bottom, this section here is 2 pi RH. Okay, so R is going to be the radius of the cylinder. H is the length here, or the height of the cylinder. Okay, now that's important to know. So this y, if you look at it, the distance y up to y, that is the radius of that cylinder, right? So that's why we have y there. Now if the radius, and we'll show on the next problem, this is number 17, we'll show how that shifts if the radius is not, if the axis of rotation is not on one of the axes. So that is the radius. This, if you take the right hand minus the left hand, so you always start on the right hand equation minus the left hand, that's going to give us this distance, which is the height. In this case, see how this cylinder is, so this cylinder is actually sideways like this. So that gives us the height of the cylinder is the distance between these two equations. Now that distance between those two equations is different at every y point, right? So, okay, so looking at this now, so we calculated before that this crosses right here, this shares a point, and this shares a point. Now remember, when we're doing with respect to y, these values have to be in terms of y as well. So our equation now is going to be x equals, or let's actually not do x equals, let's do this, 2 pi integrated from, now remember we're looking at where it's integrated in respect to y. So these cross each other from 0 up to 1 in the direction of y. So this is from 0 to 1. Y is going to be just the where on the y-axis, how far it is from this x-axis, or y equals 0, is the y value. So that would give us our radius of our cylinder. So this is still just y. And then we're going to take the right-hand equation, which this equation is the equation that is y squared plus 1. So if you look at your review sheet. And then you're going to subtract from that this equation, which is x equals 1. Okay, and then this is with respect to dy. Okay, so let's look at now going through number 18. So this one has a little bit more detail to it. I should have moved on and tried number 18, and maybe it would help me see the mistake I was making. Anyway, so as you graph this, we get, so you get 2 parabolas. Okay, so, and this is another giveaway. If they tell you the equations in terms of x equals, then you can go ahead and assume that you are differentiating with respect to y. If they give them to you in y equals, then you're differentiating with respect to x. So that's kind of a, and then remember too, for cylindrical shells, it's when the cylinders or the sections, the cross sections that you're cutting out to create those cylinders, those cross sections are parallel to your axis of rotation. Because if they are perpendicular to your axis of rotation, that creates a washer or a disc. Okay, so we have these two equations. One of them, this one, if you look at it, is actually an x squared function. So this is what creates this is going to be, I know I just graphed a couple of the points. Sorry, I was going to go through all the calculations this time because you guys said you didn't really need that. But this is going to be a parabola of some sort. Sorry, I don't know where exactly it crosses there. And then this is going to be a sideways parabola. So I'm not going to be super precise, except for that this little section in here is what we're looking to find if we rotate that around the axis, y equals -2. Okay, so we're rotating around way down here. Okay, so this is where it's rotating. And this little section is where we're rotating. Now remember, the sections are parallel to the axis of rotation. Okay, now we're going to go through and fill in. So we know we have 2 pi. And here, when you find your equations and things, you see that in the y direction, they cross at y equals 0 and y equals 1. So it does still go from 0 to 1. Now comes y. Remember, this y represents the radius of your cylinder. So if you're thinking of your cylinder as this is the length of the cylinder, and then if you think this is where it's rotating around, it's going to be going all the way around here, right? And this is the width of that cylinder. I don't know if you can kind of see my cylinder there. Because it's rotating all the way around down here, y is just this distance here. So to get this distance for the actual radius of the cylinder, we have to go 2 more beyond this axis. So y then would be y plus 2 more away. So see how this is the y, and there's 2 more to the axis. So that is the value of the radius. So that has to be adjusted for the equation. Then here we're going to take the right-hand equation minus the left-hand equation. So the right-hand equation, this one here, is this equation. So we're going to have square root of y plus 1. It'll help if you label them probably. So that one goes to this one goes to that one. The left-hand equation, we're going to subtract from that. So it's going to be subtracted by y squared plus 1. and that is in terms of y. Okay? Okay, so hopefully that is much more clear. Let's go ahead and go through number 19 and 20 also, and then when you're doing your practice test, I want you to try those on your own, and hopefully you'll be able to use these examples to be able to help you with those and be able to get them right. If you have any questions on Monday on those, you need to message me so that we can go through more detail if you're still not understanding how to do this. Okay, so number 19. So you have your two equations. You've got y equals the cube root of x. Now remember, it's in terms of y. Let me say that again. It's solved for y, which means that it is in terms of x, right? Because it would be y of x or f of x, where x is your variable. That's what's changing, okay? So we are going to be doing this in terms of x this time. So we also have the line y equals 0 and the line x equals 1 that are enclosing our space. And the axis of rotation is at x equals 2. Okay, so now let's go through and let's find, first we need a little picture of what the graph looks like. So we have our equation, the cube root of x, which just is okay, and then we also have this line y equals 0, and so if y equals 0, that's the x-axis. That was my mistake before. Make sure that y equals 0 is the x-axis. X equals 1. Okay, so this is x equals 1. This is y equals 0. And this one here is the cube root of x. Okay, so we are rotating now around the line. Hopefully this will make more sense too of why the other one was the way it is. We're rotating around the line x equals 2. So this is our axis of rotation. So that's what we're rotating around. Okay? So if that's what we're rotating around, and here, this is the section. Remember, our cylindrical shells are parallel to our axis of rotation. Okay, so that's the direction the shells are going to go. Now we have that same equation, but now we're looking at it in terms of x. So for instance here, we know that these cross over from graphing it, that they cross each other at 1, right? Because this is x equals 1. So we are going from 0 to 1. And this is the little section we're looking at. Now we need to know what the radius of our cylinders are. So the radius is from this value, whatever the x value is, around all the way around here. I should give a different color than that, sorry. So this is, the cylinder is making this whole round right here. Okay, so if this is the cylinder, then we think of the radius. This distance here is x, right? But the radius is not what x is, right? The radius is over to 2 minus that. It's whatever goes all the way over to 2 minus that little part x. So the radius is 2 minus x. Okay, so see the difference between that? The other one added radius on. This actually, because it's shifted over and you're going through this rotation axis, you have all the way over to 2, but then we're going to subtract that little x value. Okay, so that is the radius of number 19. And then we still need to find what the length of the cylinder, the height of the cylinder is. And that's going to be the top equation minus the bottom equation. So we'll have cube root of x minus y equals 0. So let's just minus the 0. And that is in terms of x. The variable that we're working with is x, and that's what we're going to be taking the derivative with. Okay, okay, let's do number 20. I hope I'm not moving too fast. I hope this is making a little bit more sense too. If I could have someone needed to tell me that y equals 0 is the x-axis, not the y-axis. So I just mixed that up, and that was the whole downfall. Okay, so on here now we have y equals 2x plus 1. We also have y equals x squared plus 1. So I need to slow down, watch this video, and then try and do these problems on your own after you watch them is probably best. And then you can look back for help on it. Okay, so our axis that we're rotating around is x equals -4. Okay, so let's get these graphs graphed. So this graph is a linear function that goes through 1 and has a slope of 2. And this one, and you probably want to be a little bit more specific graphing them, but this goes through So this is the section that we're looking at. Now remember that it tells us that the axis of rotation is around -4. So we're going to go to x equals -4. And this is where we're rotating it around, okay? So now we have these that will be parallel to our axis of rotation. And they're going to, each one of these is going to create a cylinder that goes all the way around this axis of rotation, right? If that's where it's rotating around. So first of all, we have 2 pi. We're looking in the x direction of where these two cross. And then when you're being more careful on here, you'll know that this is actually at 2 is where they cross. So this goes from 0 to 2. And we need to know, first of all, what is the radius of our cylinder? Well, the radius here we know is x, right? So this distance is x. But then we still go all the way over to -4. So if you do x plus 4, that gives us the full radius of each of these segments. Then we need the height of each of these segments, which is going to be the top equation minus the bottom equation. So we get the 2x plus 1 minus x squared plus 1. And then we are differentiating or integrating with respect to x. Anyway, so go through, do the practice test with those problems. You need to be ready to do really well on that on the test. So if you have any questions, I want you to first try doing these on your run your review. So watch the video and then go through, do all 4 of them on your review. Make sure you understand them. Do the practice test. Make sure you're getting those correct. And if you have any questions, if you're not able to get those correct, you need to ask me a question on Canvas to go through some things some more before the test on Wednesday. And try not to leave it to last minute because I do have a busy schedule to fit in things. So, okay, let me know what questions you have after the video. Thanks.